Okay, so today we're diving into something that I think is really interesting. It's kind of like a snapshot of where we are with some of this cutting edge AI stuff.
Oh, yeah.
And it's all centered around this new benchmark called PaperBench.
Okay.
And when I say benchmark, think of it kind of like a standardized test, but instead of like measuring a student's knowledge, PaperBench looks at how well AI agents can understand and even reproduce advanced AI research. Like we're talking about, some of the toughest stuff out there, like actual published papers.
Yeah, I mean, imagine like handing an AI, a research paper. That's basically like the blueprint of a complex AI innovation, right?
Yeah.
And then saying, hey, can you rebuild this from scratch?
Yeah.
That's essentially what PaperBench is trying to do. It's not just about, reading and understanding the paper. It's about actually grasping the concepts, writing the code that's necessary to implement it,
Right.
and then running the experiments and seeing if they can actually achieve the same results as the original researchers.
Mm-hmm. Yeah, and for someone like you who's interested in AI and follows this stuff, why is this a big deal? Why is this something that like catches your eye?
Well, because it kind of gives us a sneak peek, right?
Yeah.
Into what AI can actually do today.
Yeah.
What are its capabilities? What are its limitations?
Right.
Especially when it comes to like these more complex research tasks, right?
Yeah.
Can they do this autonomously?
Yeah.
Can they actually do research on their own?
Right.
And it's also, as we'll talk about, it raises some really interesting questions about AI safety.
Right, exactly. Yeah. Okay, so let's like break this down a little bit more, like concretely. What does it look like when an AI agent is trying to replicate a piece of research using PaperBench? Like, what are they given and what are they asked to do? Yeah,
so the AI agent is given the full research paper, like the actual full PDF document, the same one that you would read if you were trying to understand it.
Oh.
And the task is to replicate the paper's empirical contributions. And I think maybe it's helpful for you to understand what empirical contributions actually means, right?
Yes, absolutely.
Because that's kind of like a jargony term.
Yeah, break that down.
So really what it boils down to is reproducing the key findings of that paper, right? So, they read the paper, they understand, what experiments were run, what results were obtained, and they have to try to get those same results.
Gotcha, okay.
And how do they do that? Well, they have to develop their own code, right? From scratch. They can't just like look at the author's code, the original author's code, and copy it.
Oh, interesting.
Right? They have to come up with it themselves.
Okay.
And then they have to run those experiments,
Yeah.
They have to monitor them. They have to like debug them if something goes wrong. So it's very similar to what, a human researcher would do in a lab, right?
Okay. Now, these papers that they're being asked to replicate, these aren't like simple, like intro to AI assignments or anything, right? This is the leading edge of the field.
No, this is like the bleeding edge.
Yeah.
This is like, the most advanced stuff that's being published in AI research today. In fact, the paper mentions that for human experts, for people who have PhDs in AI, it can take several days of focused effort to replicate just one of these papers.
Wow, several days. Okay. So to give like a little bit more context, what kind of like topics are covered in these papers? What are we talking about here?
Yeah, so to give you an idea of like the scope of this, right? They're not just looking at like one little subfield of AI. They're actually looking at a very broad range of topics. So PaperBench uses 20 research papers.
Okay.
And these papers were presented at a really big machine learning conference called ICML.
Okay.
This is one of the top conferences in the field. And in particular, these were the papers that were, recognized as being particularly significant. Like they were, spotlight or oral presentations.
Okay, so like the best of the best from this conference.
Yeah, exactly. So we're talking about, really high quality research here. And these papers cover things like deep reinforcement learning, which is all about, training AI to make sequences of decisions.
Right.
Robustness, which is about making AI systems more reliable, even when they're faced with unexpected data. So like, making sure that your phone app still works, even if your internet connection is a little bit shaky.
Right. Okay.
And then probabilistic methods, which are all about, helping AI deal with uncertainty. Right?
Yeah.
Because in the real world, there's always uncertainty.
Right.
And so these are just a few examples, but in total, they cover 12 different topics.
Wow.
Within machine learning. So it really is a broad benchmark that's testing AI's research skills across a wide range of areas.
Okay, so it's not just like one specific AI or one specific problem or anything like that. It's a pretty wide scope here.
Yeah, it's a very comprehensive evaluation.
Okay. Now, here's a question that I think a lot of people are probably wondering. Like, how do you even judge if an AI has successfully replicated a piece of research? Like, this isn't like a math problem, right? Where there's like a single right answer.
Right.
It's a little fuzzier than that.
Yeah, and this is actually one of the, I think, the most impressive aspects of this work.
Okay.
Is how they address that question.
Yeah.
Because it is tricky, right? Like, how do you say, okay, this AI did a good job or this AI did a bad job?
Yeah.
So what they did is they came up with this idea of author-approved rubrics.
Okay.
Okay, so what does that mean? So for each of those 20 papers, they work directly with the original authors of the papers, right? The people who actually did the research.
Gotcha. So the people who really, really know this stuff inside and out.
Exactly. And together, they created a very detailed set of guidelines for evaluating a replication attempt. Imagine like a giant checklist, right?
Yeah.
That's broken down into thousands of tiny little tasks.
Okay.
And each task has clear criteria for whether it's been done correctly or not.
Okay, so instead of just saying like, oh yeah, this replication was good or this replication was bad, you can actually like pinpoint exactly what the AI was able to do, what it struggled with.
Exactly.
And this is really important for actually measuring like the core scientific contribution, right? Like, was this AI able to like reproduce the actual essence of this paper or not?
Exactly.
Okay.
So across all 20 papers, we're talking about over 8,000 individually gradable tasks.
Wow. Okay, so 8,000 things they're looking at. So I'm guessing they didn't like sit there with a red pen and like go through all these 8,000 items for every AI they tested.
Well, that was actually the next challenge, right?
Yeah.
Because imagine trying to grade all of that manually.
Yeah. I mean, I grade, my kids' homework sometimes, and that takes forever.
Exactly.
I can't imagine doing this 8,000 times.
And the paper actually estimates that it would take tens of hours per paper for a human expert to do that.
Wow.
So, if you're trying to run this benchmark at scale,
Yeah.
you just can't do that.
Right.
It's not practical. So they also developed an automated way to grade these replications. And they did this by creating what they call an AI judge,
Okay.
which is based on a large language model. And they call this judge Simple Judge.
Okay. So we have an AI that's trying to do research, and then we have another AI that's judging how well it did the research. That's pretty meta. But how do we know if that AI judge is any good?
Right. So that's a really important question.
Yeah.
Right. Because how do we know that it's not just, assigning scores randomly?
Right.
So to evaluate the performance of their AI judge, they created another set of evaluations. But this time, the evaluations were specifically designed to assess the performance of judges.
Okay.
Okay, so it's like evaluations for the evaluator.
Right.
And they call this judge evils.
Okay.
And they compared the scores given by Simple Judge to a set of gold standard evaluations that were done by human experts.
Okay.
Okay, so they had, humans who really understand this stuff grade a subset of these replications.
Yeah.
And then they said, okay, how well does Simple Judge match the judgments of those human experts?
Gotcha.
And their best version of Simple Judge achieved an F1 score of 0.83 on this Judge Evil.
Okay, so for people who are following along, an F1 score of 0.83, while not perfect, is generally considered pretty good in this kind of setting. So that suggests that the AI judge is, it's doing a reasonable job.
Yeah, it's not perfect, but it's a good starting point.
Yeah, it's doing a reasonable job at figuring out, how well these AIs are doing.
Yeah, exactly.
Yeah.
And it's a lot more efficient than having humans grade everything.
Right. Yeah, exactly. Okay, so we've got AI doing research, we've got AI judging AI, we've got like this whole big loop going on here. So what were some of the key findings when they actually ran this whole like system?
Well, I think the most striking finding is that even the best performing AI agent that they tested only achieved an average replication score of 21%.
21%. Okay. So to give you some context, like how does that compare to how well humans did?
Yeah. So to get a sense of that, they had a group of machine learning PhD students.
Okay.
These are, people who spent years studying this stuff.
Yeah, they know what they're doing.
You know what they're doing.
Okay.
And they had them try to replicate a smaller subset of the papers.
Okay.
Just 3 of the papers.
Okay.
And they gave them 48 hours.
Okay.
So they had, a good chunk of time to work on it.
Yeah.
And these human experts achieved an average replication score of 41.4%.
Okay, so roughly double what the AI was able to do.
Yeah, so there's a pretty significant gap there, right?
Yeah.
Even with all the progress that we've seen in AI,
Right.
it still has a ways to go.
Yeah.
before it can match the ability of human researchers,
Yeah.
at least when it comes to these complex research tasks.
Right, right. I mean, 21% versus 41%. I mean, that really underscores how difficult this is. What were some of the specific areas where the AI agents were struggling? What were some of the challenges?
Yeah, so they identified a few key challenges. One was they called long horizon tasks. So, replicating a research paper isn't just about, doing one quick thing.
Right.
It's a project, it's a process. You have to think about, okay, what are all the steps I need to take? How am I going to approach this?
Yeah.
How am I going to plan my time? And the AI agents often had trouble with this.
Okay.
They would, kind of lose focus, or they would prematurely think that they were done with the task.
Yeah.
Even if they hadn't actually fully accomplished the goals.
So it's almost like they're not able to hold the big picture in their mind long enough to actually complete the task.
Yeah, they might be able to, understand the individual steps, but they have trouble stringing them together.
Right, right. Okay, that's interesting. What else?
Another challenge was in consistently using tools.
Okay.
So the AI agents were given access to various tools that could help them.
Yeah.
Like a command line interface.
Okay.
A way to run Python code.
Gotcha.
A web browser.
Okay.
Right. But while they could use those tools effectively sometimes, they often struggled to integrate them smoothly into their overall workflow.
So it's like they have the tools in the toolbox, but they don't really know which one to use when.
Yeah, or like how to use them together effectively.
Right. Okay.
So it's not just about understanding the research conceptually, right? It's also about being able to translate that understanding into practice.
Right.
And being able to use tools effectively to actually get things done.
Right. Like you can read a cookbook.
Exactly.
But that doesn't mean you can cook.
Exactly.
Okay. So you mentioned a bunch of really interesting things here. Was there anything else that stood out to you when you were reading this paper?
Yeah. So I thought it was interesting that they also introduced what they call a more lightweight version of this benchmark called PaperBench Code Dev.
Okay, Code Dev. What's that about?
Yeah, so this is a simplified version that really just focuses on code development.
Okay.
So instead of having the AI run the full experiments and actually reproduce the results, they just have them write the code.
Okay.
And then they evaluate the quality of that code.
Gotcha.
Based on those rubrics.
Okay.
And what's really interesting is that they found that performance on this code-focused benchmark was only weakly correlated with performance on the full PaperBench.
So in other words, just because the AI can write code that looks correct doesn't necessarily mean that it can actually use that code to get the results it needs. Okay, so it's like it's one thing to write a recipe. It's another thing to actually bake the cake.
Exactly.
Okay. So stepping back a little bit, thinking big picture now, what could happen if we actually did develop AI that could do this? That could autonomously do research like at the level of humans, or maybe even better?
I mean, that's a really big question, right?
Yeah.
And it's a question that I think we need to be thinking about very carefully.
Yeah.
Because the implications are huge.
Yeah, absolutely.
On the one hand, the potential for accelerating scientific discovery is enormous.
Yeah.
Right? Imagine having AI assistants that can not only read and understand complex research, but also independently come up with new ideas, test them, verify findings,
Yeah.
I mean, the paper even suggests that this could significantly speed up research on AI safety.
Oh, interesting.
Which is, a crucial topic these days.
Right, yeah, absolutely. I mean, that could be huge. But there's probably a flip side to this, right? I mean, there's probably some things we need to be worried about.
Yeah, absolutely.
Yeah.
So that leads us to the other side of the coin, right? Which is that, what if the pace of innovation gets so fast that it outstrips our ability to understand the consequences.
Right.
And put in place adequate safety measures.
Right. Because if an AI can not only replicate research, but also improve upon it.
Exactly.
And then do it again and again and again, the speed of progress could just become so fast that we can't even keep up.
Exactly. It's like this exponential growth of knowledge and capabilities.
Yeah.
And, it's great if we can control it and steer it in the right direction.
Right.
But it's also potentially very dangerous if we lose control.
Yeah.
Right.
So, one of the things that I was thinking about as I was reading this paper is okay, so this benchmark is out there now, right? And it's what happens next? Is this just something that this one research group did?
So this is actually one of the things that I was most excited about.
Okay.
Is that the creators of PaperBench made the whole thing open source.
Okay. They made it public.
They made it public.
Okay.
So all the code for the benchmark is available online.
Gotcha.
And they've also said that they plan to release the rubrics
Okay.
in the future.
Okay.
So all those detailed guidelines for evaluating replications.
Wow. So they're really like opening it up to the world. Like anyone who wants to can look at this, can try it out.
Yeah, and this is really important because it allows the entire research community, other scientists, engineers, even just hobbyists who are interested in this, to like dig into this themselves.
Yeah.
Right? They can try to replicate the results. They can build upon the work. They can test their own AI agents.
Yeah.
And it basically creates this kind of like collaborative effort to improve our understanding of these advanced AI capabilities.
So it's not just about what this one group did. It's really about like opening up a whole new area of research for the entire community.
Exactly. And I think, the more people we have working on this, the better our chances are of like really understanding what's going on.
Yeah.
And, developing AI safely and responsibly.
Right.
So, I mean, for you, the listener, I think this is a really important takeaway. Like, pay attention to this stuff.
Yeah.
Right? Think about the potential implications.
Mm-hmm.
What does it mean for the speed of scientific progress?
Yeah.
What are the ethical questions that we need to be asking?
Absolutely.
As AI becomes increasingly capable of, doing research on its own.
Yeah.
It's a fascinating area, and it's an area that's only going to become more important in the years to come.
It really is. And I think it's something that everyone should be paying attention to because it's going to affect all of us.
Yeah.
Great. Well, this has been a really, really fascinating dive into PaperBench. Thanks so much for breaking it all down for us.
Yeah, no problem.
And to all of you listening, thank you so much for joining us on The Deep Dive. We'll see you next time.